Welcome back to the deep dive. We've got a really interesting source this time, maybe a bit different. It's a product specification sheet, specifically for the WolfPack 1x4 HDMI splitter.
Yeah, it sounds maybe a little dry, just a spec sheet.
Yeah.
But honestly, the mission here is pretty significant. We're not just looking at, a little box.
Right.
We're using this sheet as a kind of guide, really,
Yes.
a crash course in modern high-def video.
Uh-huh.
We're talking 4K at 60 hertz, HDMI 2.0A, HDCP 2.2, all the stuff you have to understand if you want to send these big 4K signals around without messing them up.
Okay, yeah, looking at the top line specs, they jump right out. It takes one HDMI in, splits it to 4 HDMI outs. Pretty standard idea for a splitter.
Uh-huh.
But then you see 18 gigabits per second bandwidth, full HDR support, and, crucially, HDCP 2.2 compliant on all the ports.
Exactly. Those three. That's like the checklist now. If you want top-tier video distribution, you need those. Miss one, and you're either losing quality or, frankly, you might just end up staring at a blank screen.
Okay, let's unpack this. Let's start with that big number, 18 Gbps. Why 18 gigabits per second? What is all that bandwidth actually for?
Well, that 18 Gbps, that's basically the minimum entry fee for the full, proper 4K experience today. It's dictated by the HDMI 2.0A standard.
Ah, 2.0A.
Yeah, and it was a huge leap from the older standard's maximum, which was, 10.2 Gbps. The splitter needs that 18 Gbps pipeline.
Why, though? Just because 4K is bigger?
Fundamentally, yes. 4K resolution is 4 times the pixels of 1080p. So think about it, 4 times the information. If you want to push all those pixels smoothly, especially quickly, you just need a much wider pipe.
But hang on, didn't the older standard HDMI 1.4, didn't it claim it could handle 4K already? What was wrong with that? Why the big jump?
A good point. Yes, HDMI 1.4 could technically carry a 4K signal, but it was really limited. Seriously handicapped.
How so?
Could only do it at like 24 or maybe 30 frames per second. Fine for movies, maybe, but anything fast.
Yeah.
Sports, games, it looked choppy, jerky.
Okay, so motion suffered.
Big time. And not just motion. HDMI 1.4 also limited 4K to just 8-bit color.
Right, so the benefit of hitting 18 Gbps with HDMI 2.0 is really about getting both smooth motion and better color fidelity.
Absolutely. That bandwidth lets this splitter handle video all the way up to 4K at 60 frames per second, 60 hertz. That smooths everything out. That's the difference people really see.
And the color part, the spec sheet mentions something. YCBCR 4.4.4 sounds very technical.
It is a bit technical, yeah. But think of it like this. 8-bit color, the old standard, is kind of like a compressed image file, like a JPEG. Looks okay, but there are limitations, banding and gradients sometimes.
Okay.
YCBCR 4.4.4, especially at 10 or even 12-bit depth, which 18 Gbps enables. That's like the raw, uncompressed file from a camera. Zero color compression.
So much richer colors, smoother transitions.
Millions more colors, literally.
Huh.
Super smooth gradients. It means, like the spec sheet says, you're getting the finest 4K picture you can get. That's the goal. What's fascinating here is it's not just about the resolution and the frame rate anymore.
Mm-hmm.
Getting that finest picture also means nailing the color enhancements and, the copy protection.
Let's hit color first then. HDR, high dynamic range. We hear about it all the time. How does the splitter supporting it actually change what you see on screen?
Okay, HDR, fundamentally, it's about contrast, making the difference between the really bright parts of an image and the really dark parts much, much bigger, more dramatic.
It's more realistic.
Yeah, more depth, more pop. Think of like a dark scene in a movie, maybe just lit by a candle. HDR makes that candle flame really bright and intense, but you can still see all the details lurking in the shadows around it. It avoids that washed out look.
Got it. Okay, now the part that gives everyone headaches. HDCP 2.2 compliancy. Anyone who's tried linking gear together knows the pain of that black screen. Why is this copy protection so aggressive?
Hey, aggressive is a good word. HDCP 2.2 is the latest digital handshake. It's what movie studios, Netflix, 4K Blu-ray, DirecTV, they all demand it for their premium 4K content.
And if something in the chain doesn't support it?
Black screen. That's it. The source device literally just refuses to send the video signal. Anything. The source, the splitter, the cable, the TV isn't fully HDCP 2.2 compliant. It's an all-or-nothing deal.
And the spec sheet specifically calls out the kinds of devices that need this, right? Roku 4, DirecTV Genie in 4K, Amazon Fire 4K, even some AV receivers. If you have that kind of gear, this compliance isn't optional.
Nope, it's absolutely mandatory. Table stakes for modern 4K? Oh, and a small useful detail from the sheet, it also mentions DVI 1.0 compatibility.
DVI, that's an older connection.
Yeah, But it means you could potentially use this splitter with some older professional gear, maybe monitors or projectors that use DVI, just by using a simple HDMI to DVI adapter. Adds a bit of flexibility.
Okay, let's shift gears to how this thing manages signals. You split one source to 4 screens. Rarely are those screens identical, right? You might have a brand new 4K TV in the living room, but maybe a 1080p monitor in the office connected to the same splitter.
Exactly. Big problem, potentially.
So how does the source device, the Roku or whatever, know what kind of signal to send out? This is where EDID comes in, I gather.
Precisely. EDAD, Extended Display Identification Data. It's like a little name tag that each display wears, telling the source device, here's what I can handle, revolutions, refresh rates, audio formats.
And the splitter has to manage potentially 4 different EDIDs talking back to one source.
Right. It's the negotiator.
Yeah.
And because those screens often don't match, this WolfPack splitter gives you 2 ways to handle it. 2 user-selectable EDID modes.
Okay, walk us through mode number 1, STD mode.
STD mode, standard mode. This is your simple, safe bet. When you select this, the splitter basically ignores what the connected TVs are saying. It just uses its own built-in, very basic EDAD.
What does that ED tell the source?
It tells the source, hey, just send me 1080p video at 60 hertz and basic 2-channel stereo audio. That's it. Nice and simple.
Why would you use that? Sounds like a downgrade.
It's the fallback. If you're having weird issues, flickering screens, no signal, maybe one TV works but another doesn't, switching to STD mode forces a universally compatible signal. It sacrifices quality, maybe, but it usually guarantees a picture. The spec sheet even says it's recommended if you have display issues in the other mode.
Okay, which brings us to the smarter mode, TV mode. This is where the magic is supposed to happen.
This is where it tries to give you the best possible result, yeah. In TV mode, the splitter does something clever. It only listens to the EDID from the display connected to HDMI OUT1, just that one port.
Output 1 is the master then.
Kind of. If the display plugged into OUT1 sends back an EDI saying, I can handle 4K at 60 hertz, HDR the whole 9 yards, the splitter blows it, and then it tells the source device to send that full quality signal.
And it sends the high quality signal too.
To all 4 outputs simultaneously. So if OUT1 is your best display, all your other connected displays will also receive that top-tier signal.
Okay, here's where it gets really interesting. What if the display in OUT1 isn't your best one? What if it's only 1080p? Or what if OUT1 is 4K, but you also have, say, an old 720p screen plugged into OUT3?
Ah, right. That's the key intelligence here. If the splitter reads the EDD from OUT1 and it's not 4K capable, or if it senses that one of the other displays downstream can't handle the format requested by OUT1.
Then what? Does everything drop to the lowest quality?
It does something smarter. It effectively polls all the connected displays. It figures out the highest resolution and refresh rate that every single display connected can actually support.
Ah, the highest common denominator, not the lowest.
Exactly. So it prevents your oldest, weakest display from dragging everything else down. If 3 screens are 4K and 1 is 1080p, they'll all likely get a 1080p signal in this scenario. It tries to maximize quality for everyone without leaving any screen behind with a no signal message. It's a smart way to handle mixed resolutions. While we focus so much on the picture, HDMI 2.0 also brought some pretty big upgrades on the audio side, too.
Right, the spec sheet mentions boosted audio channels.
Massively boosted. The old standard topped out around 8 channels of audio, for typical 7.1 surround. HDMI 2.0 expanded that capacity all the way up to 32 channels.
32 channels, that's a lot. Like professional cinema level.
Getting there, yeah. It allows for much more complex sound systems, like Dolby Atmos with height channels and things like that.
Yeah.
Plus, HDMI 2.0 improved the dynamic synchronization between audio and video. Helps kill those annoying lip sync issues.
And for the audio files, the supported formats are top-notch according to this sheet. LPCM 7.1, Dolby True HD, DTS HD Master Audio.
Yep, all the lossless high-resolution formats. So this splitter isn't just handling the best video, it's ready to pass through the best possible sound, too.
Good stuff. Anything else jump out from the physical specs? Build quality, support?
Yeah, a few practical things. It mentions a durable metal chassis, which is nice. Not cheap plastic. It's pretty small and light, 165 grams. But the interesting bit is the ESD protection.
ESD, electrostatic discharge.
Exactly. It specifies protection up to 8 kilovolts for air discharge, 4 kilovolts for contact. That basically means it's built to withstand static shocks or minor power surges that might happen when you're plugging things in, or just from the environment.
So it's less likely to die.
Hopefully. It points towards more robust, maybe commercial-grade internal design, not just basic consumer electronics. That, plus the mention of a 1-year warranty and lifetime US-based phone support, suggests they expect it to be reliable.
Okay, so pulling it all together, we started with just a spec sheet for this WolfPack 1x4 splitter. But what we've really unpacked is how a device like this acts as a kind of gatekeeper and manager for all the complexities of modern 4K video. The 18 Gbps bandwidth from HDMI 2.0A, handling HDR, enforcing HDCP 2.2, and intelligently managing ED. It all has to work together.
So what does this all mean for you if you're trying to set up a multi-screen 4K system? It means the hardware really matters. You need devices specifically designed for these standards, especially if you have screens with different capabilities. You can't just assume any old splitter will work correctly.
And that EDI logic we talked about, particularly in TV mode, has a really practical consequence for setup.
Oh, absolutely.
Yeah.
Because that smart TV mode relies entirely on reading the capabilities of whatever display you plug into HDMI OUT1. Well, you need to be careful what you plug into OUT1.
Right. If you put your best 4K TV on OUT2, but your older 1080p monitor on OUT1.
Then that 1080p monitor on OUT1 is going to dictate the signal for everyone. Even if your main TV could handle much more, the splitter, in TV mode, will likely only request a 1080p signal from your source device because that's what OUT1 reported.
So here's the final thought. If you're setting up a system like this, using a smart splitter with EDI management, have you actually checked which display is plugged into that critical HDMI OUT1 port? Are you sure your best display is connected there, or could you be accidentally limiting the quality for all your screens because the wrong device is plugged into the priority port?